हेलो एवरीवन। इस लेक्चर के लास्ट पार्ट में हमने बात की द ओवरलैप ऑफ मशीन लर्निंग विद डेटा माइनिंग, और उसमें हमने मशीन लर्निंग के डिफरेंट पार्ट्स डिस्कस किए एज क्लासिफिकेशन विच इज़ अ काइंड ऑफ सुपरवाइज्ड लर्निंग, क्लस्टरिंग विच इज़ अ काइंड ऑफ अनसुपरवाइज्ड लर्निंग। सो ये वो पार्ट्स हैं मशीन लर्निंग के दैट आर बीइंग ओवरलैप्ड विद डेटा माइनिंग ऑल्सो, और ये कॉन्सेप्ट्स आपको डेटा माइनिंग में भी मिलेंगे। अपार्ट फ्रॉम दैट, डेटा माइनिंग ऑल्सो हैज़ association rule mining, which is like finding the relevance between different features, or outlier detection or anomaly detection is also of interest to us in machine learning, क्योंकि हम जब किसी मॉडल को ट्रेन करेंगे, so if that data has outliers, it means that there are instances that do not go well with the base distribution of the data, जो बाकी data points से बहुत मुख्तलिफ हैं। So in that case, if you train the model on such data that has such issues, so even we may be using good models, but the results may not be good enough. So therefore, we need to prepare our data, get rid of such issues before providing that data to train a model. So the part of data mining, that is classification, clustering, and outlier detection or anomaly discovery, is something that is of interest to us in machine learning also. Particular examples of these cases would be find all customers that are likely to miss one payment. So this is a kind of classification. So the label over here is that people who are going to miss their payments. So we can assume that the label data would be such that we would have features of all the customers, and the label would be 0 for missing the payment, 1 for not missing the payment. So if we have a trained classifier on this data, we can perform this task as a classification problem. An example for clustering is group all customers with similar buying habits. So based on how frequent the customers are buying, based on what items they are buying, in which times they are buying, so based on the similarity of their buying patterns, we can group them together. And once we have these clusters, we cannot explicitly say what each of these clusters represent. So the model will help us to separate all these customers into different groups, but we would not have meaningful information about each of those clusters. Just like in case of classification, we know that one part of users will not miss payment and the others will. So that is not the case with clustering. We may have 5 clusters and they may all have different behaviors, and each cluster is going to have strong similarity of their behavior, but we cannot identify that behavior by the clustering algorithm itself. An example of association rule mining is list all items that are frequently purchased with bicycles. So over here we are finding the relevance between different items. Bicycles are being purchased and we want to see what items are purchased with it. So we are not particularly interested in the customers who are buying it, but we are rather more interested in which items are more purchased with which other items. And as we said, outliers are simply the unusual customers. It may be due to some entry problem in the data, or it may actually be a customer who is very different from the rest of the customers. So this is part of data mining that we would often see in machine learning. As we observe, all of this analysis can be performed by finding patterns from within the data. So data mining has considerable difference with database operations. In case of database operations, we know what we are looking for, and that information is explicitly mentioned or available in the database. As we can see in the examples, find all customers that live in Islamabad. So over here we would have a feature that would be named like living in or residence, and there will be values like Islamabad. So we are going to construct a query that is going to pick all customers who have their location or home equal to Islamabad. So in case of database, the information that we look for is explicitly available in the databases. The second example is find all customers that use MasterCard. So we would have this information in our database. Find all customers that missed one payment. So in the past, if we have records of all the customers and their payment history, we can find all those customers who have missed those payments. So this is what we do in database systems. We write queries in order to extract information that is already available. In case of data mining, we try to predict the future based on what we have. So just as we saw in the database part, if we look into all customers who have missed one payment, and based on that we train a model in order to predict who is going to miss their next payment, so that would be part of data mining. So in data mining, we predict something that isn't explicitly mentioned in the databases. We use the databases, but we rather use it as past history, and based on that, we try to predict the future. So that is the difference between database operations and data mining. All these data mining techniques that we use in machine learning also are based on pattern recognition. The model looks into thousands and hundreds of thousands of records and try to find similarity or repeated patterns, and then it establishes an association with those patterns. So pattern recognition is basically the main theme of the data mining approaches, that is clustering, classification, outlier detection, association, rule mining. So let's just see what pattern recognition is, and for that we are going to do a little activity. So let's play a quick game. I'm going to show you some classification problems which were shown to pigeons. Let us see if you are as smart as a pigeon. So this is the first of the problems. The problem is we have some instances, and these instances belong to class A and class B. So this is the data that we have got. These are the observations or the observable data, and based on this we may predict the label of any unseen instance. So as you can see, label A has got instances with features 3 and 4. Then we have another instance that is 1.5 and 5. So we may actually represent this data in the form of a structured way that we saw in the previous lecture. So it would be something like this. We have instances that have just two features represented here by the first and the second column. So let's call them F1 and F2. And we have got instances. So the first instance, let's call it O1, has got a value of 3 for the first feature and a value of 4 for the second feature. And the label for this is A. Then the second instance, O2, has got the first value is 1.5 and the other is 5, and it also belongs to A. And the same way, we have the rest of the instances that belong to class A, and then all the other instances that belong to class B. So this is our problem space, and we have to train a model on this data in order to predict the label for any unseen instance. So this is basically a representation that is more easier for us humans to visualize the problem, and this is how it's being provided to the model. Okay, so now the unseen object that is being provided to us in this case is having the first feature value is 8 and the second feature value is 1.5. So if we have to classify this object to either class A or B, we'll have to see what relevance it has got with A and B, and the class with which instances it has got more relevance, we are going to label this instance into that class. So if you look into all the objects of class A, we can clearly see a pattern in it, and the pattern is that F1 has got a smaller value as compared to F2. Whereas if we look into all the instances of class B, we can again see a clear pattern that F1 has got a higher value as compared to F2. So if we see all the instances follows or obeys this pattern, so it's a clear pattern, it's a clear indication to differentiate between A and B, and that's what we mean by pattern recognition. And this pattern recognition is the soul of data mining and machine learning approaches. So now the problem gets quite easier. 8 is greater than 1.5, so this unseen instance belongs to class B. The same way, the second example is 4.5 and 7. In this case, the first value, that is f1, has got a smaller value as compared to f2, which has got a value of 7, and therefore it clearly belongs to class A. So as you observed, even in our mind we identified the patterns, then matched the objects with the patterns in each of the labels, and then predicted the label for an unseen instance. So that's how our mind works or approaches a problem, and we would want to have models that would do exactly the same for us, because we have a limitation. We can look for such patterns in 8 instances, 10, maybe 20, but after that it would be a lot difficult for us to identify these patterns if we have millions of instances. The same way, in this case, we have just 2 features. So 2 features can be easily visualized to come up with a pattern. But if we have 50, 100, 80, 150 features, so at that level of complexity, it's very difficult for humans to identify such patterns manually. However, the way we identified these patterns for just 4 or 5 instances, this intuition can be provided to the model in order to do exactly the same at a much higher scale for more number of instances, for more number of features. So as we correctly identified, this instance with f1 is 8 and f2 is 1.5 belongs to class B. So now we get to another problem, that is the pigeon problem 2. Again, we are given instances that are being labeled as A and B. So these instances that are already given in class A and B is basically the ground truth. The same way in this example also, what we are already provided is the ground truth. Ground truth in pattern recognition is something that you trust. If you do not trust these values or their labels, then it's very hard to identify patterns. So we need to have something that we can trust so that based on it, we can learn something new. So this is the ground truth, and we are going to blindly trust that all the instances over here are correctly labeled. So now again, the problem is to classify this unseen instance that has got f1 value of 8 and f2 value of 1.5. Again, we'll have to look for a pattern that is frequently repeated in the instances of class A and B, and then observe that which of the patterns is more related to the one that we have got in this unseen instance. So if we observe over here, we can see that all the instances in class A have f1 and f2 values equal, as the first instance has got 4, 4, then 5, 5, 6, 6, and 3, 3. Whereas all the instances that belong to class B have different f1 and f2 values. In some cases, the f1 value is greater, while in others, the f2 value is greater. So the pattern over here is that if f1 and f2 have equal values, so that it belongs to class A, otherwise it belongs to class B. So considering that rule, the first instance that has got f1 value of 8 and f2 value of 1.5 belongs to class B, whereas the second instance with both values as 7 belongs to class A. So these are the results of the problem. And now we move to the third problem, which is really hard at the pigeon level. Again, we are given with examples of class A and B, and we have a test case to identify which class it belongs to. So as we can see in class A, there are instances that have feature values equal. For example, the first object has got 4, 4 values for both f1 and f2 features. The second instance has got f1 value smaller than f2. The third instance has got f1 value greater than f2. So we have all possible cases in A that were previously used as patterns, and we have all those possible cases in class B also, because in the first instance we have f1 smaller than f2, then the second has got f1 greater than f2, the last or the fourth instance has 7, 7, which has f1 equal to f2. So we have all those patterns that were previously helping us classify between the two labels available in both class A and B. Now, it doesn't mean that there isn't any pattern that is going to help us in classifying this unseen instance. However, the pattern in this case is quite complex. It cannot be identified just by merely looking at these values. We need to think about it and then observe that there is actually a pattern, but that pattern is a lot harder as compared to the previous examples. So if we again observe all the objects of class A, we can see that the values are rather on a shorter side. For example, the first object has got both the values as 4, 4, then 1, 5. Then the third object has got one bigger value, that is 6, but the other value is quite more smaller, that is 3. And the third has got the values of 3 and 7. So as you can see, the last object has got the sum of F1 and F2 10, while all the others are having the sum of their two features less than 10. So the values are generally on the smaller side. If you look at the values of F1 and F2 for class B, the first one has got value of 5 and 6, which is greater than 10. Then 7 and 5, again greater than 10. 4 and 8, 7 and 7. So the values are, although there isn't that clear pattern, but the values are comparatively higher as compared to class A. Or we can simply say that if the sum of the two features is less than or equal to 10, it belongs to class A. Otherwise, it belongs to class B. Now, if you look at the unseen instance, 6 plus 6 is 12, which is clearly above 10, and all the instances that we have in class A do not have such pattern. It's more like the instances of class B, so we can classify it as belonging to class B. The rule that is provided over here is that if the square of the sum of the two bars is less than or equal to 100, it is an A, otherwise it is a B. So this is another way of what we said earlier. The sum of the two is either 10 or less than 10 in case of A and otherwise B, and we can also observe it as the way provided over here, which is the square of the sum of the two values is less than 100 or equal to 100 in case of A, otherwise it's B. So there is another way of looking into the same problem. Now we are visualizing the same problem that we observed earlier, just to show you that by visualizing the problem, it gets a lot easier to look at the pattern that we were trying to identify for problem 1. So as you can clearly see, there is a pattern between the instances of class A and B, and basically our job to classify the unseen instance is basically to differentiate between these two types of instances, and then when we have an unseen instance, we can compare it with the two types and see to which label it belongs. So by visualizing the data, we can clearly see a pattern between the instances of class A and B. This is the data or the representation of class A and B, where the objects of class A are along the diagonal because they have their F1 and F2 values equal, while on both sides of the diagonal all the instances belong to class B. So again we have a pattern, and we can clearly identify such pattern that is going to help us to classify the unseen instances. The third problem that was relatively harder is again quite simplified when we represent the data visually, because over here again we can see that all the instances that are close to the origin are actually the ones belonging to class A. As we said, they have relatively smaller values, while all the instances that are away from the origin are the ones that belongs to class B. So there is a pattern again, and our job is to identify that pattern or have machines identify those patterns for us. For us, when the data is visually represented, we can come up with patterns a lot easier, but the problem is that the data is generally not two-dimensional, and therefore we cannot represent it visually. Secondly, the data over here is based on simple dummy examples, and therefore they are clearly separable. The real world data is not that clearly separable, and we have some overlap or cluttering of data, and there are outliers and other issues. So before identifying patterns and training a model, we would first look into all those problems and try to resolve them. So to conclude this, we need to write codes that can help machines identify these patterns using different statistical measures, so that these patterns can be identified from millions of instances with hundreds of features, and then based on those features we can decide the label or the group of an unseen instance. Thank you.